um, started the recording
We
right
just
now,
started
so we can
recording.
get things going.
Okay, great. Okay, welcome everyone. Thank you for taking the time to be here for this awesome occasion. We really appreciate Dr. Gosling's time, for taking the time to speak with us at Georgia Tech and respective universities. I know that we probably have universities all around the country, given our previous uh, turnout. Um, Dr. James Gosling, Order of Canada, has worked on all kinds of software from ground analysis for telemetry, from the international satellites for ionospheric studies to satellite to the original Unix Emacs, the NEWS Windows system, and the Java programming language, of course. His PhD thesis was on the algebraic manipulation of constraints. He had some wonderful years at Sun Microsystems, where he was best known as the original developer of the Java programming language. He spent over 5 years hacking the control software of autonomous ocean-going robots. He just finished 7 years at Amazon Web Services, and he's now retired. Um, Congratulations. Um, and his specialties are graphics, languages, embedded systems, and distributed systems. Is there anything there that hopefully that was all correct?
Good enough.
Okay. Um, so without further ado, if we could give a massive virtual applause for Dr. James Gosling, who took the time to join us today. Awesome. Thanks, everyone. With that said, I'd love to take it into just if Dr. Gosling, if you're comfortable, like just taking
Yep.
into question and answer, so we can just uh, learn new things and discuss. Um, how we usually do it is audience members or participants are welcome to raise their virtual hand. And once you've raised your virtual hand, we'll be able to call on you, and you'll be able to ask your question verbally uh, through the through our teams. So we welcome questions, and I'm very excited for some people to have some very thoughtful questions.
Yeah, and ask me absolutely anything.
Okay, awesome. So we will wait for the first hand to be raised, and that's going to be um, Jeff Garbers, at Georgia Tech. Love to hear your question if you want to
Thank you,
speak.
Dr. Gosling. An
Absolutely.
honor to see you here. I never expected to have this opportunity, and what a delight. A bit of a personal one, if you'll indulge me, as a nerd of a certain age with retirement looming. I'm curious as to what your plans are as far as staying up to date or staying involved in new aspects of software development in your retirement years. Is that something that you anticipate continuing to maintain interest of, or are you like I am tending to do, sort of ready to leave it all to the new smart kids coming along the pike?
Um, I don't think I could ever do that. And I'm retired in double quotes, which basically means I don't have a full-time job. Um, but I happen to live sort of in the venture capital heartland of Silicon Valley, and I've got a bunch of friends doing that stuff. And one of the things that I end up doing these days is people send me stuff to review, which mostly causes me to like either erupt in laughter or just go, "Fuck." Um, and I've been starting to do bits of consulting and stuff, and one of my favorite activities is just building stuff. Um, so I build stuff. I mean, and building stuff is the way I have mostly kept up to date. I'm, I mean, I am literally a bad reader. I'm in like the 10th percentile of reading ability. Um,
I don't believe that.
no, I actually am. You give me a reading competence test, and I'm pretty crappy. Um, but it changes if my motivational structure has changed. So if I'm working on something and I need to know something, um, it works a lot better for me. So I just build stuff.
Thank you, sir. That's heartening. That was sort of my plan as well, to be able to do that and explore things casually and according to personal interest. And good to hear that somebody else thinks that's a viable plan too.
Yeah, yeah. I mean, all my life I've had, things I need to do and things I want to do. And the things I want to do have always taken second place. And now that's flipped.
Awesome. So again, I'm welcoming people to raise their hands, and we already have a hand. Uh, Professor Lee, I see you have your hand raised. Would you like to ask your question verbally? I think you're on mute. We can't hear you.
All right, so is it better?
Yes, perfect.
Okay, all right, yeah. So first of all, me as a personal note, I was a PhD student under Gail Kaiser at Columbia. So I think when Java first came out, Gail said, "Yeah, let's go for it." I had a great time programming in Java, almost 30 years ago now. So my question to you is that,
well, and Gail and I were grad students together at CMU.
exactly. Yeah, she mentioned that yeah, as well. My question is that, given all these, I don't know whether it's true or not. I think that's increasingly, people are using ChatGPT to do programming, right? So at least some of the programming tasks. What's your view of the future of programming? Do people still use language like Java, or do you use higher level logic kind of statements, and the rest let AI take over it?
Well, okay. So how many hours do you have?
I know it's difficult, but I think
that's kind of the gateway drug of questions.
yeah.
Let me get started on. So like the you ended with the thing about using formal methods and all of that, and that's in a pretty decent state. And I'm definitely a fan. It still doesn't scale terribly well, but if you're doing like an encryption algorithm, or lots of folks are using these tools to build provably correct, sort of low-level security algorithms. And that's working really well. I'm pretty happy with the way that goes. Nobody's managed to take any of those and scale them up to large systems. But for doing these sort of nuts in the middle, these sort of diamonds that need, a very skilled diamond cutter to make them and be correct, and where the consequences of errors are extreme. That's been working really well. The whole Gen AI thing, personally, I don't think it's past the party trick stage. So the way Gen AI works is you train it on a whole lot of code, and then you ask a question of it, and it gives you something. And so Gen AI works on the kind of things that are well represented in the code bodies out there, right? So if you ask for a sort algorithm for an array of integers, it's probably going to do just fine.
Mm-hmm.
As soon as you start asking about, and you know, that's the kind of thing that people mostly don't do because there are standard libraries
Right.
for sorting arrays, right?
Right.
As soon as you start to get into more complicated things, right? So if you ask them, um, I need a control algorithm for a tractor that takes GPS inputs and a map and plots out an optimal plowing pattern for a field. You're not going to get anything useful.
Mm-hmm. Mm-hmm.
You know, if you know, and so the really low level simple stuff, these Gen AI systems are doing fairly well for things for which there are almost no examples.
Mm-hmm.
And in the training set, you know, if you're doing something that is derivative, that is looks like things that thousands of people have done before, then it'll work okay. Um, which means that, like, if you're a university student, you'll probably, you know, and you give it the text of an assignment you're doing. Um, it's a decent chance it'll give you a half-assed idea.
Mm-hmm.
But the thing about assignments like that is that they're all small. Um, you know, they're all small, and it, there's a dramatic amount of training data out there. But stuff like that also gets turned into libraries very quickly.
Mm-hmm.
Right? If you like in just the Java ecosystem, the number of libraries is huge. And in you know all of the successful languages, the libraries are huge.
Mm-hmm.
And so people tend to do something a number of times, and people figure out that, oh, algorithms that sort are used everywhere. So why don't we do one? Or, you know, and then they get polished and optimized, and, you know, it's just not possible for a normal human to beat some of the sort algorithms that you find in these libraries. They tend to be, you know, tuned to within an inch of their life.
Mm-hmm.
So just never do that, right? So the stuff that Gen AI is good at, mostly people don't do,
Mm-hmm.
right? But if you've got, you know, something that you can't find in a library, um, which is, you know, like I want to be able to connect people who want to travel in the streets of New York with cab drivers and be able to do route planning for them. You're not going to find that,
Mm-hmm.
right? And you know the Gen AI, it's kind of looking in the rear view mirror, right? If you wanted to do something new and unexpected, something that would require more reasoning. Gen AI doesn't really do reasoning. I mean, people are struggling hard to get reasoning into Gen AI frameworks.
Mm-hmm.
Um, but, you know, they're still having a hard time doing simple stuff like getting math to
Mm-hmm.
work.
Mm-hmm.
Um,
So in many regards, we're just not there. Like we could, the potential could be,
it is still a fertile field for PhD
yeah.
thesis.
Yeah. Okay. That's great. I mean, I can tell my students, hey, don't worry about your job being replaced, you should basically think about how to do your job better with AI, right?
Well, and you know, the place where people seem to have been successful with AI and programming is in learning. You know, it's like, how would you sort an array of integers in PHP?
Mm-hmm.
How would you support an array of integers in Snowball?
Hmm.
Well, it's probably not going to have a good answer for that because nobody's used Snowball for 30
Right.
years.
Right. Yeah.
Um, and so, you know, it's you know, it's a this and that.
Okay. Great. Yeah. Thank you.
Kind of, I was just actually going to piggyback off that question just because I was curious. In terms of like, it seems like ChatGPT can create like code for, I guess, very simple things. Seems to be the consensus that we're talking about. And correct me if I'm wrong,
Yeah.
but do we is there do we see a future where people that don't know how to code are going to be able to leverage their creativity and like pretty much it'd be these technologies are not at the point where someone that doesn't know how to code would be able to build professional grade software.
No, not
Yeah.
even close.
Okay. Yeah. Okay. Awesome. So I guess let's see. Junsu.
Hi, Dr. Gosling. I'm Terry from Georgia Tech. It's an honor to meet you. Um, I have a more high-level question. So I too want to build things, but as a student, I have constraints for resources and time. Were you ever in a situation where you wanted to work on something, but you needed to persuade others to be able to do what you want? Like, how do you persuade people as someone who builds things? Like, do you have insights on that?
I guess I've never had much success in saying to people, please help me build this. Um, However, what has been really successful for me is building prototypes, building initial implementation, you know, building demonstrations, and then instead of saying, please help me, saying, look at this, it's really cool. Wow, there is so much to do to make it be something really useful. And then you know, often people will go, can I help? Um, and that works pretty well. You
Thank you
know,
so much.
it's you know, carrots rather than sticks, and um, just trying to suck people in. You know, it's you know, when you build something, one of the hardest things is to get people to understand why it's cool. You know, and it's all about storytelling. What is the story that you can tell? And you've got like 30 seconds, right? How do you get somebody excited about something quickly? If you figure out how to tell the story before they get bored, um, and you can get people kind of like sucked in, um, you can do pretty well.
And then let's see. Urshavi or Urvashi, sorry. Urvashi, you have your hand raised.
It looks like they're on hold. Um,
Oh, they're on
maybe they
hold.
got a call. Yeah.
Okay. Um yes, again, we invite questions and raise your hand and I'll gladly call on questions. And then we have another one from, let's see, Dr. or Jeff Garbers.
Yeah, it's me again, man. As long as there's nobody else in line, I'll take
Yeah.
these opportunities whenever I can. This is awesome. Dr. Gosling, the group that I work with is responsible for helping to identify and support opportunities for commercialization of Georgia Tech research all over the campus. It's often challenging for us to do that in computing because so many of the ideas that are coming out of computing research are sort of fundamental and low level and don't necessarily have immediate practical applications, right? You show me a new algorithm or a new optimized way to do encryption or something, I can't jump immediately from that to, oh, therefore you should, let's talk about a startup or let's talk about a license of this technology for some particular application. Clearly, you've had great commercial success with the things that you've invented. I'm curious as to you can offer some guidance for me and my colleagues as to how we can do a better job of supporting uh, folks who are doing more fundamental CS type research in identifying commercial applications for those things.
Um, that's really, really hard. Um, and that's, it's partly because, you know, there's so many issues here, right? So like, how do you get a successful product, and what is your metric for success, right? So if you so like if you think about the venture capital industry, right, and you talked about appealing to venture capitalists, one of the big problems with venture capitalists is they they wouldn't know a good idea if it slapped them in the face. Um, and they wouldn't know a bad idea if it slapped them in the face. By and large, um, the venture capital industry is style. It's like Vogue magazine. Um, and if something pops up, so I mean, the way that they tend to work is stuff pops up in the press, like when the OpenAI guys, showed these demos of Gen AI, then all the VC companies go, "Ooh, that's cool." They don't really know why it's cool, and I actually think it really is cool, but not in the ways that they think it is. And then it's like every VC joins the herd, right? And they start oozing money out of every pore of their body. Um, and fundamentally, they don't care whether the companies succeed, which may sound like kind of odd. Um, all that they care about is that they can sell their portion of the company to the greater fool. It's like the greater fool theory of stock markets, right? You don't have to succeed. There just has to be somebody more foolish than you that you can sell your stock to. And that is fundamentally the heart of venture capital. So from the point of view of a university trying to sell their stuff, um, talking to venture capitalists um, is nuts because they have there are a few people in some of these venture capitalist companies that have vision and knowledge. They're few and far between. Um, and I've got a circle of friends who are kind of those people, but they have a hell of a hard time persuading their partners to invest in things that make sense. Um, and often you find on the inside of venture capital companies, people make these deals where they say, okay, I'll let you invest $1 billion in X which by the way is a stupid idea and you're going to burn it all. If you let me invest $100 million in this thing over here, which does make sense. And I've been involved in those multiple times. So it's stupid. And trying to, be sort of like outbound and proactively reach out to folks like venture capitalists. Oh man, I am a total cynic on the venture capital world. But then I've been in the middle of it for 40 years, so um,
That makes sense.
but I've had a lot better luck with things like the press, although they tend to be the fashion industry too. They're very much the fashion industry, but it's a game. And these days, you're really looking for a channel that can reach the people whose existence you know nothing of. Right? So, if you've come up with some cool algorithm, the challenge is that there's somebody out there that is just dying because they don't have this.
But you don't know you don't know how to.
You don't know who they are.
Yeah.
Right. And, if you've got a complete soup to nuts product, yeah, you could maybe go to a VC and you could at least have a conversation, even if, you're out of the style zone. But, that's been one of the places where open source has been really successful in getting exposure for people. But then, as a university, one of the things that you have to do is make sure you can pay everybody's salaries, which means somehow or other getting revenue off of that. And that's a loop that people have a hard time closing. And there's kind of there's a real problem in the whole ecosystem around licenses. Because universities on average would like licenses that will let them somehow or other recoup some value from, what they have funded. And that is, as near as I can tell, perfectly reasonable. But as soon as you start laying boundaries, then that stops people from even looking at it because they like don't know what this is, what it, how, if they start using something, the worst case scenario for, some random corporations, they start using something, they go, oh, this is cool. This really changes the way we do things. And then some lawyer walks in and says, just a minute, you're using the free evaluation copy and you don't know how much it will cost. You're going to make a commitment to something, and then the provider of that is going to walk in and say, $1 billion, please. Right. That's, that gets really tough. And also the open source licenses are things that people actually understand. Right. So if you're somebody, in some software development group at some company, if you're pulling in something that's Apache 3 or Apache 2 and you want to use it, the Apache and BSD and MIT licenses, people go, that's okay. We understand it. But there's no path to revenue from those licenses. And the GPL licenses, they have a bunch of catch clauses that turn people off. And I don't know of any well accepted licenses that have a path to revenue. So sorry, I'm short on ideas here.
And then let's see. And then Urvashi, I told you that. Do you does your mic work now?
Yeah. Hi. Can you hear me?
Yes.
Yep.
Yes.
Hi, sir. It's a really big honor to talk to you because this is like one of the first languages I learned, like Java. But yeah, just because we were talking about AI and how it tends to be like a starter for people, like wait, I'll phrase this better. Because people tend to avoid getting into proper development because and take the shortcuts to AI because there's no like right one way to enter that area. Do you think it makes sense, or is there any value in developing like a lingua franca for development, and so it makes it easier for people to enter that sphere?
Oh, everybody thinks they're developing a lingua franca.
Oh yeah.
Right.
I
I
always
mean, you can write anything in C, you can write anything in assembler, you can write, and then somebody comes along and says, well, I've got a better lingua franca. And what makes a language good is very context dependent. And the actual language doesn't make much of a difference one way or the other to a Gen AI model.
So do you think it makes sense for us to, so if we have context-specific languages, then how do we extend the lifespan of those? Because I think the main issue I've heard from people is that it doesn't last very long and there's always something new coming up in the area.
Languages last longer than you think. The amount of COBOL code out there is mind-boggling. You just don't see it. The amount of Java code out there is much more mind-boggling. You just mostly don't see it. You get programming languages that sort of find a home in a niche, like Python is kind of the lingua franca for AI. And one of the things I find somewhat hilarious about that is if you actually try to write AI algorithms in Python, you're going to be very sad because AI is extremely compute intensive and Python is very slow. So what Python is really used for is gluing together pieces of C and assembly code. And so is it the best language? I don't know. Um, it's just different. There are different trade-offs you make. Um, the Python folks, Python doesn't scale very well, but it interacts with C really well.
So context specific, like you said.
Yeah.
Thank you so much.
And then William, your question.
Yep. Hi. So yeah, I'm Will. I'm from the University of Toronto. So I kind of wanted to ask sort of a high level field level view. So you mentioned that you said like Gen AI isn't really past the party trick stage. So sort of as like a young person who's interested in like the AI space, but kind of looking for what niches are gonna maybe last a little bit longer or have better job prospects, what do you think are some of the more promising directions to look at? I figure as somebody who has a lot of history in the field, or at least history in programming in general, you might have better suggestions than I can come up with. So,
Um, so the way I'd like to think about it is to start with AI is a toxic term, right? The term AI people use as this umbrella over a huge number of techniques. And pretty much all of these techniques are statistics of various sorts. And, with some level of inferencing. And it's sort of like inferencing by statistics, but some of them are not. I mean, some of them are um, kind of finding optimums by doing, y- y- you know, there are things called relaxation algorithms that have been around for decades. And when you add a certain amount of randomness to relaxation, you can get yourself to simulated annealing. And a bunch of AI algorithms are these kinds of statistics at truly massive scale. And when you hear about people, like news headlines like AI has solved protein folding, it just makes me furious because that's not what's happened there. A bunch of really smart humans did a bunch of statistics on known ways that protein molecules fold, and then use that as a way to evaluate ways that unknown, the protein molecules of unknown physical structure can fold because they can sort of reason from past patterns. And I'd feel a whole lot better about the AI world if people would stop using the term AI and just start saying advanced statistical techniques, right? And just be unabashed about the fact that we're using gobs of horsepower to analyze gobs of data to tease out the patterns, right? This is humans doing work with really advanced tools. And when you look at it that way, um, you can start seeing that you take any domain and you can start figuring out ways to improve them, right? So you take some place where we've got gobs of data, like vehicles traversing roads, and you try to do the standard Dijkstra's algorithm, shortest route, But that doesn't factor into it, well, this one goes by a school and that one's going through a shopping district. And you don't know any of that, but you can kind of infer that by looking at the statistics of millions of vehicle transits through that area. And so then it's like, are you using AI to magically figure out a good route? Or are you intelligently using statistics to tease out the better patterns? And, as soon as you start thinking from the point of view of the domain where you're trying to solve a problem, and then go from there to the tools, I think you end up in a better place than if you say, I've got a tool. Where can I use it? Right? It's like the old line about, if you're a hammer, everything is a nail.
Mm.
And it's like, don't do that. Open up the AI label and look at this like wide set of tools that you have, and marvel at the incredible amount of compute power that we have available now, and figure out which pieces of that apply to whatever the problem is in front of you. If you're trying to find the squirrels that are stealing the bird seed out of your bird feeder, and you're trying to aim a squirt gun at it, well, maybe you'd use a different set of techniques. But shooting squirrels with squirt guns is hilarious. So you've made the world a better place.
And then, Dr. Gosling, I just want to be like cognizant of your time and how much time do you have left? Because I just don't want to,
I can keep going.
Okay,
No
just want
problem.
to make sure.
I also
then-
tend to give really long-winded answers, so.
And then Meow Meow Zhao?
Yeah. Hello.
Okay, hi.
Hi. It's a great honor to meet you here. So I want to ask something that is not very technical. I'm more curious about how do you allocate your time as when you were a student and um, as a software engineer, and especially sometimes I want to build something, but I'm worried that this thing which I want to build may be too trivial, and I don't know if it's worth my time, and I sometimes very confused about what's the most intrinsic things about computer science, and what's the most tech new techniques come and go. So how do you decide if a techniques is worth your time? And yeah.
So I have a pretty simple algorithm for that. I call it the shiny object disease. If I see some technology and it looks all shiny and sparkly, I go, ooh, that looks like fun. And I go there. I don't, well, I rarely try to come up with it like a big model of, what is the most important thing going forward. I learn best when I'm fascinated by something. So if something engages my mind, I go there.
So just kind of like work on fun and cool.
That's kind of my, except that, you know, I've had many counterexamples in my life, right? So, for instance, you know, when I was in college, I hated numerical analysis. Then when I got to grad school, um, I had to do you know, one of the qualifying exams was numerical analysis. And the guy who was the head of numerical analysis at Carnegie Mellon was a guy named H.T. Kung. And he was an absolute ball breaker. Um, and man, passing, you know, getting through the numerical analysis qualifier, um, man, did that hurt. Um, and yet, numerical analysis is a skill that I've found I've used over and over and over again. Now, most people don't have careers that go that way because floating point arithmetic is something that most people are barely aware exists because it's kind of, you know, this low level underlying thing. But that's a place where doing something that I was kind of like forced to do. But that was, you know, I think the differentiating thing there is that, you know, like the people who set up the PhD program at Carnegie Mellon, um, you know, they had a little more perspective than I did as an incoming PhD student. And so they had some impressions of what things were valuable. But I didn't, right? I mean, I thought that numerical analysis was deeply stupid. Um, and so I kind of use like the modified shiny object theory, which is I just follow shiny objects. But if somebody that I trust says that thing over there is worth looking at, then I kind of force myself.
Cool. Thank you very much.
And then David?
Yes, hello. Dr. Gosling, thank you for spending time today to talk to us. So my question is, having now retired, what side projects are you looking forward to in retirement?
Well, I'm kind of in the midst of learning the Apple platform tools. I've never actually used those. So I'm currently in a project where I'm, you know, learning how to use Xcode and write iPhone apps. You know, mostly I've done embedded programming and cloud programming. So I'm, you know, trying stuff in a different direction. I've got some friends like 2 lives ago, I did a bunch of autonomous vehicle navigation stuff that I would love to get back to. And I've got one friend who's trying to get me to do some of that as part of the consulting gig. So yeah, I mean, there's stuff everywhere.
Awesome. Thank you so much.
And then Jeremy?
Hi, Dr. Gosling. It's great to have you here today. Thank you for coming. But I'd imagine that in the early days of developing Java, not everything went smoothly. So what are some challenges that you faced when making key design choices for the language, and what do you think you learned from them, or would you do anything differently?
Um, so people tend to think of doing something like programming language design as being a technical problem. And, for the first 15 minutes of the project, that's kind of what I thought. And then it became quickly clear that it was more of a social problem. Because as soon as you've got people who are using something, they have opinions. Um, and how you deal with user communities. And one of the things that was a real luxury in the Java project was that for the first couple of years there were only about 20 users, so I could actually talk to them really easily. The downside, of course, is that they knew where my office was, um, and they could come and whine at me. Um, and I guess one of the best skills I learned was how to have a thick skin. And I, developed this sort of principle that I wouldn't do anything unless at least three people asked for the same thing. Um, and then, tried to, relentlessly get people to attack each other rather than me. Um, and the initial design of Java being sort of a seductive version of C, that was very much a social engineering trick to try to get C developers and C++ developers into thinking that this thing was something that they understood, even though it was much more rocket science. Um, having multi-threading, real multi-threading, and real garbage collection um, is very different from anything that most developers from the C++ tradition get there. So a lot of it was the sort of social engineering of subversion. So that people would they would ask me about, well, how do I free objects? And just say, don't worry about it. It's magic, right? And the amount of technology underneath garbage collection is mind-boggling, truly mind-boggling. Um, a simple garbage collector is pretty straightforward. A stupid garbage collector, like a reference counter with I believe most Pythons use, that's reprehensible. But the really good ones are magic.
Wow.
And the sign of any really good technology is that it's invisible. But yeah, it's the technology problems are by and large easy. It's the social engineering problems.
And then it looks like we're just about at the end of the hour. Do we want to take any more questions or
Oh, do
wrap
one
up?
more. Do
Okay.
one more.
All right. One more question.
Do you have a question?
I do actually. I'm curious, like, what your opinion is on on the Apple Vision Pro and like the virtual reality space. If you have like an interest in this area, or if you.
Um, I'm really fascinated.
Okay.
I was really, so I've got fairly bad eyes. And I was kind of crushed that I can't use the Apple Vision Pro because my eyes are sort of out of
Oh
spec
yeah.
for what it can handle.
Yeah,
And and I had been really excited about it because they're the first people that really took the bioengineering pieces really, really seriously. When I was working on my PhD thesis, my thesis advisor was a guy named Bob Sproul. And if you look up Bob Sproul, and also a guy named Ivan Sutherland was on my thesis committee. Um, the two of them together, they did the very first head-mounted display. Yeah, look up Bob Sproul and Ivan Sutherland,
yeah.
and a project called the Sword of Damocles. Um, and it looks, and Ivan and Bob had a venture capital fund, and they kept funding people who were trying to do, virtual reality glasses. Um, and then like when I was in my rather brief tenure at Google, they were trying to get me to work on the Google Glasses thing. And the Google Glasses folks were spending zero time on the bioengineering things. And, people would, it's pretty common that people put on these virtual reality glasses and they have a headache after not very long. And that's entirely because the designers have not spent any time on bioengineering. But that said, um, the sort of head-mounted display thing for a lot of tasks feels like a great solution for many, many things. The most compelling example I've ever seen was a company that does architectural design of interiors. And they do things like office buildings and hospitals. And hospitals turn out to be a complex thing to design. And a lot of the complexity is actually the social engineering part of trying to get, the doctors and nurses and other staff to give you comprehensible feedback on a design as to how it will, how the workflows will work. So what this company had done is that they had a big room, and it had position sensors, and they would bring in doctors and nurses and hospital staff, and they'd all put on their virtual reality glasses, and they would wander around. And I I got to like wander around in one of these mocked up hospitals. Um, and it was incredibly compelling, right?
Right.
A nurse could walk into a room and go and you'd ask them, so what would you do? And they would reach their hands out to where they thought to where the image of the tabletop was. And they'd say, those shelves are in completely the wrong place. They should be there. And, you know, in another room, right, there's a bunch of people using the CAD software, and they would move it around. And, a lot of people like nurses and doctors in that, um, they're used to being in a space and thinking about in a space.
Mm-hmm.
Um, and if you show them diagrams of something, they their mental mappings don't work that way. But if you can put them in the space, then all of a sudden the whole thing flows a lot better. And that's like the most compelling example I've seen of something that like really, really works. But, there are piles of other things like, um, FPV drones. Man, those are fun. I mean, you kind of get to
So
pretend
yeah,
you're Superman.
I'm very into the Apple Vision Pro and everything.
Yeah,
It's
no, and I
incredible.
and um I think there's a real there. I'm just not entirely sure what it is.
Yeah, I think it's possible. It's like just like a very niche market for like I don't know. Like I think there's a social stigma to it as well that like outside of like someone like me, like a nerd, like I think so, like common I think the average person is like less. It just doesn't seem like, and Apple has the price point very like the average household can't afford a Vision Pro. So
Yeah, but
yeah,
if it's a toy, it's a toy, right?
yeah, yeah,
Right. The question is, how do you make it useful? So like,
yeah,
um, could you make it so that like, you see a large construction crane or
yeah.
some piece of, construction equipment. Would it be better for the operator to
Hmm.
not be in the device,
Hmm.
but instead be, you know, projected to where the device is, but have cameras from a lot of different
Hmm.
viewpoints?
I guess you have to think about like the business costs in that respect as well, because a lot of businesses are probably very cheap, and like if they'd be willing to invest in a product like that, I guess it would save them time, money
Well,
in the long
so
run.
so so like I grew up driving tractors. Um, and for any of you who have ever done the drive a tractor in a farm on a farm, field, if you're plowing or um, baling hay or whatever it is, um, driving a tractor is one of those things where it is 99% complete monotony and about 1%. Ooh, that's interesting. How do I get around a badger hole? Um, is that really a bit of swamp there? There's, and so, you see what a lot of companies have been doing is these like semi-autonomous vehicles where, for the boring part of the job, the vehicle is completely autonomous. But when things get weird, a human pops in, and those are getting kind of
Hmm.
interesting.
Hmm.
I mean, a bunch of the autonomous car companies do that. People like Cruise Automation. Um, they have a bunch of remote drivers, and Waymo does that as well. Where if they get outside of their comfort zone, a human driver can pop in remotely,
Hmm.
and the autonomous car becomes an RC car.
Huh.
So that the humans do the hard weird bit that humans are really
Hmm.
good at, and they get to avoid the monotony.
Someone wants to know if they can get the link to the T-shirt you're wearing.
Huh?
Oh, someone in the chat asked if they can get the link to the T-shirt you're wearing. I think someone else wants to get the same T-shirt you have.
It's an XKCD t-shirt. Um, if you go to xkcd.org and look up their t-shirts, XKCD is awesome. Randall Monroe is brilliant.
There you go. So yeah, I just want to say, behalf of everyone at Georgia Tech, thank you so much, Dr. Gosling, for your time. We really appreciate it. We love to send our speakers like chocolates, if that's something if you like chocolate. We
I'm
usually
not a
send a.
chocolate guy.
Okay, well, we can try to come
Neither
up
is
with
my
another.
wife, strangely.
We can try to come up with another gift idea. I can talk to Zvi and maybe
Yeah.
Zvi can ask
Do
Bjarne or
not
something.
worry about it.
Okay. But yeah, we just want to say we really appreciate your time. Thank you everyone for coming out today. I had
Well,
a lot
thank
of
you.
fun talking about virtual reality, and
Yep.
we appreciate it.
Yep. All right. Thank you.
Okay.
Okay.
Thanks everyone.
All right. Bye.
Bye.